Hey there. We are going to take a look at some inequalities. So the first thing we're going to look at together is reading and graphing an inequality on a number line. And then we're going to take a peek at solving some algebraic inequalities. So if you're just watching this, then you can just kind of watch and listen. But if you want to go through and do this with me, why don't you pause me and go get yourself a pencil, a highlighter, and something that will write in a different color so you can kind of keep up with what we're doing. And you may also want to get a piece of lined paper if you want to go through the examples together. Now we're going to start first by reading these inequalities. This inequality says that x is less than 34. That inequality sign right there says less than. And this inequality right here says that x is less than or equal to 34. And although those two symbols look similar, they are different. There's a difference in how we show them on a number line. Over here, this inequality says that x is greater than 34. That symbol means greater than. And again, this symbol means greater than or equal to. And although they look pretty similar, they are different. This means that x can be 34 or anything bigger than it. And this means here that x can't be equal to 34. It can only be things that are above 34. Let's take a look at how those look on a number line. If I were going to graph x is less than 34 on a number line, you can start just by drawing a line. And if you put a little arrow on both ends, it means it goes on and on forever in both directions. And since we're graphing the inequality of x being less than 34, I'm going to put 34 right there in the middle of my number line. I'll go up a couple of numbers. You don't need to go more than 2 or 3 though. And I'll go down a couple of numbers. Again, going down 2 or 3 will be just fine. So there's 32 and 31. And I can graph x is less than 34 on a number line by putting a circle on my 34. Now I know it probably sounds kind of silly, but it's really important that you leave that circle open, because that open circle means that 34 is not part of what makes that true, or 34 is not part of the solution. But everything less than or to the left of 34 will. So you could highlight it on your number line just like that. And that's what x is less than 34 looks like on your number line. Now don't be too worried if you look at that and you're like, whoa, Mrs. Rudd, that doesn't make very much sense. This is just kind of to keep you hearing what you've missed while you've been out. Let's take a look at this next equality of x being less than or equal to 34. Now again, if we are going to show that inequality on a number line, we're just going to start by drawing a number line. We'll put our 34 in the middle. We'll go up a couple of numbers to 35, 36, and 37. And then we'll go down a few numbers, 33, 32, and 31. Now here I'm going to show on this number line the inequality of x being less than or equal to 34. So I'll mark my 34 on a number line, and now I'm going to fill that circle in. That's the biggest difference between those two inequalities. If you're showing me that something is less than or equal to, that number gets filled in because that number is part of the solution or part of what makes that inequality true. And because here you're showing any number that's less than or equal to 34, you're going to highlight or darken your number line going that way. And that will show less than. Let's take a peek over here at graphing inequalities that are greater than or greater than or equal to. Now using the same procedure, we'll just draw a number line. We'll put some arrows on both ends. And because we're graphing the inequality of x being greater than 34, we're going to put 34 in the middle. We'll go up a few numbers to 35 and 36 and 37. And we'll go down a few numbers, just like we've been doing, 33, 32, and 31. Now, if you're going to show x being greater than 34, we're going to circle 34, but we're going to leave that circle open. Here we're graphing the inequality of any number, that x can be any number that is greater than 34. So we're going to darken that number line going to the right. And again, it's very important that when something is less than, the circle is open, or greater than, that circle is open. Now let's take a look at graphing greater than or equal to. Again, we'll start with a number line. We're going to put 34 in the middle, 35, 36, 37. And then we'll go backwards to 33, 32, and 31. Now, to find that on the number line, you just put a circle around the spot that indicates 34. And because that inequality sign says that it's greater than or equal to, we darken that circle. And if we wanted to show any number being greater than or equal to 34, we just darken the number line going that way. Now that's just to kind of show you what they look like on a number line. But what we've been doing in class is solving algebraic inequalities. Let's take a look at a couple of those. We're going to start by looking at these two. Now, if you want to write them down so that you can keep up with me, you're welcome to do that. Or you can just kind of watch and see what it looks like. We'll talk through them. But let's take a look at these two inequalities. Here I've got x plus 12 is less than 28. And in fact, let's just focus on this one for right now. I'll cover this other guy up. X plus 12 is less than 28. And in class, we've been solving these, and then we've been graphing the solutions on a number line. Now, inequalities behave a lot like equations. And in class, we've looked at, or shown, just like we would do with those equal signs, of making a line that goes through the inequality sign. And that's to help remember that you have to do the same thing on both sides of the inequality, just like you had to do the same thing on both sides of the equation. Well, just like in an equation, we want to get x all by itself. And in order to get x by itself, we have to undo this addition. So, to undo the addition, we're going to subtract. And we have to subtract on that side as well. So here I'm subtracting 12. On the other side of my inequality, I'm subtracting 12. These two will cancel, and I'm left with x. I've got that inequality sign right there that I need to bring down, my less than, and 28 minus 12 is 16. Now, when you're solving inequalities, you do need to graph your solution on a number line. So if you use the same procedure that we used up on the top of the page, here you're going to make a number line. We're going to put 16 in the middle, since that is what we got when we simplified our inequality. We'll go up a couple of numbers, maybe 3, to 17, 18, and 19. And then we'll also mark those 2 or 3 numbers that are less than 16. And what this inequality says, or what it means here when we look at this whole algebraic inequality, is that this x can be any number. As long as it's less than 16, this original sentence right here will be true. Well, I'm just going to rewrite this sentence over here, except instead of using x, I'm going to put in a box to show you how you can test your inequality. We have a box plus 12 is going to be less than 28. Okay, now let's go back to our number line. Sorry for jumping around a little. Here I'm going to show that x has to be less than 16. So I'm going to mark 16 with that open circle. Don't fill it in. And as long as x is any number less than 16, this sentence right here will be true. Well, let's see what that looks like. Let's pick a number 14. 14 is less than 16. And let's imagine that we've got 14 in this box. 14 plus 12 is less than 28. Well, 14 plus 12 is 26. And 26 is less than 28. That is true. That's why we highlight this part of the number line, because this shows that any number from 16 keeps on going all the way down to 0 and even in negative numbers. Any number that's less than 16, if you let it stand in for x, will make that inequality true. But if we pick a number that's bigger than 16, you can see right here it's not highlighted, it's not part of the solution. These numbers won't make it true. Let me show you what I mean. Let's take out that 14. And let's just plug in 18. 18 plus 12 is 30. And if we look at that inequality, this is not true. 30 is not less than 28. That's why these numbers are not part of the solution. Now let's take a look at this guy here. J minus 7 is greater than or equal to 82. Well, following along with that same procedure, I like to draw in that line to help us see that there's math on both sides of that inequality sign. And here we need to get J all by itself. Well, in order to undo this subtraction, we need to add, since addition and subtraction are inverse operations. Minus 7 and plus 7 will cancel each other out. And on this side of the inequality sign, we're left with J. And J is less than or equal to 82 plus 7. Well, 2 plus 7 is 9. 3 plus nothing is 8. So this original inequality will be true anytime that J is greater than or equal to 89. So if you were going to show that solution on a number line, it would look like this. We'll put 89 in the middle. We'll go up 3 numbers to 90, 91, and 92. We'll go down 3 numbers to 88, 87, and 86. And in order to graph this inequality on the number line, I'm going to put a circle around 89. Now here, this sign, this greater than or equal to, tells me that 89 is part of the solution. It will be true. This inequality up here will be true if J is 89 or more. So to show that on this number line, I'll highlight to the right. And that's what that problem looks like. Now, I'm about to run out of time as far as what I can record for our video. So here's what I would like you to do. I want you to work on these 2 inequalities. K divided by 3 is greater than 9, and 7 times D is less than or equal to 28. Get a piece of paper and solve those 2 inequalities and graph their 2 solutions on a number line. And then when you feel well enough to come back to school, you bring me those 2 problems. That way I can check your answers and we can make sure that you understand what you need to do as far as solving inequalities are concerned. If it helps you, draw that dotted line down the middle of your inequality sign so you remember to do math on both sides of that inequality sign to isolate your variable. I hope you feel better soon. Bye.